Now let's create our deformer with the VEX code. Okay, so let's select all of these nodes and create a network box by clicking this icon, and let's rename this to be deformer with warp. Okay, and here let's select all of these nodes and duplicate them here. Okay, and in here let's remove the attribute warp, and instead let's add an attribute wrangle node. So this is our geometry, this is our still frame crag, okay, non-animated crag, and in here let's collect our closest primitive number and the prim UV position. Okay, so for that let's use the function called xyz twist node, xyz twist function. Okay, let's open its bracket, and if you click on this function and press F1 to bring up the help of the current VEX function, so here as you can see we have the xyz twist VEX function. So there are several ways we can call this function. So here we have the return type float, so which means it will give us the distance. Okay, and it needs the geometry and the origin, which mean the positions to sample, and also you can store the integer prim number and the UV. Okay, so here at the sign mean that this node can output multiple information. Okay, so the first it has the return type of float, which means the by default it will return the distance, and it also can output the primitive number and the vector UV position. Okay, so here let's type float twist. Okay, so because the distance is a float attribute and the return type is float. Okay, and for storing the primitive number and the primitive UV, let's create a variable. So the primitive number is an integer, so let's type int, and let's call this variable prim, and let's add the semicolon. Okay, so we are initializing the prim integer variable, and but the value is empty here. Okay, because we are not assigning anything. And also let's create a vector UV, so let's add vector, let's call this one UV, and let's add the semicolon to initialize our UV variable. Okay, so now currently these two variables are empty, so let's use the xyz distance node to store the information into this variable. So first it needs the geometry, so we want the geometry from the second input. So here we can type 1, so the 0 mean first input and the 1 mean the second input, and after that the origin for the sampling position, so we want at the current line point position, so we can say at P, which means the currently processing point position, and after that the variable name to store the primitive number. So we have created a variable name prim, so let's use this prim, and for the prim UV we have created a variable UV, so let's type UV here, and let's close with the bracket and add a semicolon. Okay, so here we have a syntax error because we are creating a float distance and we need to add an equal sign. Okay, so now we are working correctly. So here we are storing the prim and the prim UV into a variable. So but for to access into the another wrangle we need an attribute. So if I middle click, so currently we don't have an attribute, so instead of creating a variable, let's create an attribute. So by saying I add sign, and after the vector v add sign, And now here we have the syntax error again, because now it is looking for variable. So currently we don't have variable. So to store into an attribute, you must add an add size. So it means that attribute, okay, add sign here. So now this node is working correctly, and if we middle click, now we have the prim and the UV position. So if we go into the geometry spreadsheet, here as you can see we have the primitive numbers and the UV positions. Okay, and after that let's add another angle, and let's disconnect it here, this one, and the animated crack to this one. And here let's add our function name prim_uv, and click on this prim_uv and press F1 to open the help for this function. So we have the prim_uv vex function, and interpolates the value of an attribute at certain parametric UV position. Okay, so here we have the return type. So type that which attribute that you want to import. So if you are importing the P, so the return type will be a vector. Okay, so let's say at P is equal to prim_uv. So here it needs the geometry, so 1, which means the second input. Okay, and the attribute name, and its syntax is string, so which means we need to add this into this column. So I want to import the P for the position. Let's end this with semicolon again, and it needs the prim_num. So we have created an attribute named prim, so let's use this attribute by adding an add sign and typing the attribute name and the prim_uv position. So here we have the attribute name UV. Let's end this, add a semicolon. Okay, so now this green line means that this will work, but we have the costing error. So it means that at prim we need to define that which type of this attribute is. So if I type I, so now it knows that it's an integer attribute. And here we have the V, so let's type V at UV, which means this one is a vector, and now we don't have those errors. Okay, and now if I set the display flag onto the merge, let's play back our animation. Here as you can see, we are creating the same deformer with the VEX code. Okay, so if you open up the help card, go to the help and to the contents, and down here onto the VEX, and scroll down. Here we have the reference to the VEX functions. So here we have all of the different types of VEX function that we can use to write our VEX code. Okay, and you can also filter them with the tags. So for example, if you want functions related to the math, so here we have this category for math. So now here we have these functions related to the math, and also for the arrays and attribute, and for the conversion. Okay, so if you click on the any function, so it will bring up the help for this function. Here we have the cos function, return the cosine of the argument, and here we have the return type name float and the VEX function, and here it needs the data type, this function, to work. Okay, so you can use this help to learn more about all of these VEX function. Okay,